So this is what I've looked at with this database. As I said, it's 25 by 25,000 firms. We've been able, unfortunately, it's not available directly. We had to manually go through every one of the 25,000 firms and look at all the other firms. So it's been sort of a painstaking process. If we look at the size of the firms, they're actually relatively large firms. They are not all public firms, so there are some private firms. However, most of the data, in terms of connections, is with public firms. If I look at the in and out degrees, so this is how many firms each of the firms in the database are connected to, you see something that looks like almost like an exponential distribution here. So there are a large number of firms that have very few connections, and then some that have very many connections. So some firms out here with very many connections, but some with very few. So we see, again, so that's the structure of this network. So the network, if I look at all the firms, some of them only have a few customers, a few suppliers, but then there are others, you know, if I put in a General Electric has lots and lots of suppliers, lots and lots of customers. Even an Apple has, in this database, 150 suppliers, about 150 customers. So they have there's a wide variety of firms that fit into this structure. So they do. It looks very unlike anything that's just linear or just a star or something that's sort of complete. So what I'm going to do is look at how firms influence each other, and using the stock price of the firm. So for these would be just for the public firms. So for firms that trade and that have a stock price, I'm going to look at two kinds of effects. One is just the direct connections they have, just how they're connected to their suppliers, and one is how central they are in the overall network of firms. So I'm going to use that as, I'm going to call that second order, although it's really sort of a centrality measure of how much that firm is in the middle of all firms. So how important then shocks to that firm should be for other firms within this global economy. Okay, so first off, I'm going to do the suppliers and customers, and then I'll do so these are the direct connections, just suppliers and customers. And I'm going to look at what happens. So if my supplier has some kind of bad event, some kind of bad shock in 1 month where maybe its share price goes down a lot, maybe there's negative news about the supplier that gets revealed that forces its price down, how does that impact this firm in the next month? And the same thing I'm going to look at for customers. Now, the customer momentum also appeared in a paper by Cohen and Frazzini in 2008, where they did see that there was a significant impact. So if your customer had a negative or a positive shock in 1 month, then that affected your own firm's price the following month. However, since they published their paper, and since now everyone knows that should be observable, we wouldn't expect to see it in the data anymore, because presumably people would take advantage of that and not let that kind of an anomaly progress. So we'd expect not to see this, but maybe this one is actually in the data. And then I want to look and see what happens to the firms in terms of this centrality. So in terms of having lots of these connections, is it good to have lots of connections, or is it not so good to have lots of connections? So that if you're connected to firms that also have lots of connections, is that good, or should you not be connected to all other firms that also have lots of connections? All right, so first off, we'll look at, so this is just for the direct connection. So this is the connections going in, connections going out. And I'm going to see whether there's a big effect from those. And so then I'm going to estimate these coefficients. So this would be the effect of, this is the own firm momentum, and this would be like its supplier momentum, its customer momentum, and then within the current period, its supplier and customer effects. And again, now this for this study, this is just U.S. firms over the period 2010 2010 to 2012. And I'm also including some other common risk factors, the Fama-French factors here. Okay, so these are the results. This says, in terms of different specifications, depending on how many things I put into the model. But in all of the specifications, if I look at what happens, this is the supplier momentum. So this is own firm momentum, that's pretty strong. This is supplier momentum, and that's significant all the time. This is the customer momentum. I said I wouldn't expect that to appear because it's already appeared in a publication, so this doesn't appear anymore. However, this hasn't appeared in the publication primarily, I think, because this data hasn't been available. So if you want to go out and start a hedge fund, here's an opportunity. This amounts to about a 70 basis point a month gain if you trade on this supplier momentum from 1 month to the next. So 70 basis points over a year, that's an 8.5% gain. So there's an 8.5% opportunity with no risk if you want to take advantage of it. However, you have to take advantage of it really fast because other people are going to know about this. Anyone else who listens to this talk or who's read the working paper that is not entirely public, but that has these results in it. So what this says is that there is an impact. So whoever it is that you connect to within this global network of firms, a shock to them is going to impact you. So shocks to your suppliers are going to impact you. Shocks to your customers are going to impact you. Both of them are going to have some effect. And so, so making these connections is something that's going to influence the firm. But we also wanted to see, well, what about whether they're connected to others? How many connections can you have? So more of the nonlinear impact of lots and lots of connections. So looking at the centrality using two kinds of centrality, either eigenvector or then just counting up how many firms you're connected to in and out. But primarily using the eigenvector centrality. So essentially taking big matrix and looking at its eigenvalues. Okay, so we'll split it into quintiles, but anyway, here's the impact. These are the factor sensitivities for in-degree centrality for manufacturer firms. And these are firms, so what I've done is split the firms up into 5 groups. So these are the firms that have the lowest connectivity among manufacturers, and these are the firms that have the highest connectivity among manufacturers. And then what you'll see is if I look at when I put in all these other factors, look at this impact. So this is the alpha. This is the constant term. So the constant term is highest for those firms that have low centrality, and it keeps on going down. Now it's negative for the firms that have high centrality. So what that says is if you're a manufacturer and you're deeply in the middle of the network, then your returns are lower. But your returns are lower actually corresponds to you're taking on less systemic risk than the firms that are up here and that are not connected to many firms. So that sort of seems counterintuitive. It seems like that the firms that are connected to more, they're going to have more connections to them. But that's just the first order effect. That's just their direct connections. What's actually happening in these firms that are up here and that have lots of connections is they're making their connections sort of strategically in ways in which they're trying to mitigate risk. So they're mitigating risk by making all these connections. Mitigating risk, lowering their systemic risk actually leads to lower returns. So higher connectivity in this case leads to lower returns. Now, what happens to firms that are in a different industry? Let's look at logistics. Now, logistics, because it's an important industry for here, but also logistics, it's an industry where often firms specialize in particular forms, either a particular region or particular industrial sector. And what we see is in this case that the effect is the opposite. So as I increase the centrality of a firm, then in this case, the returns get higher. So if I look here, it was minus 0.3, 0.3, 0.2, about the same, 0.7, and then up to 0.9. So now, for firms that are in logistics industry, being more central in the network, in other words, having more of these connectivity connections from those kinds of firms, at least by in-degree centrality, more of those connections actually increases returns, increases risk. Now, I think what happens here is that firms are they're taking advantage. They have maybe an entry into a given region, and then they try to build on that entry. And building on that entry is just exposing them to more and more risks from the same sort of area, and therefore increasing their risk.